See this, if u equal to ax plus by plus cz, v equal to ay plus bz plus cx, and w equal to this one, we are supposed to prove that the product of these two determinants is equal to this one, right? So for that, what I'll try to do is, see clearly the answer is in terms of u, v and w, but here it is ABC and here it is XYZ. Therefore, you have to convert the product of these two determinants into UV and W. So you have to multiply them in such a way that it can be written as UVW, right? So for that reason, I am taking, you can take, see, if you observe this one, if you observe both the matrices, they are symmetric, right? Just see this. If you observe this one and this one, they are symmetric. Therefore, since I told you, whenever these two matrices are symmetric, either you do it in any multiplication, any order, you are going to get the same result, right? So what I am trying to do here is, here I am taking row by column multiplication. You could take row by row or column by column, any multiplication for that matter, because both are symmetric, right? So see, what do I mean by row by column? I'll just take this. If you have two determinants, one is 3 by 3 and other is 3 by 3, two determinants, let's call it delta 1 and let's call it delta 2. And now if you are getting a new determinant delta 3 as a product of these two determinants, and if you are applying row by row let us say you are applying row by column multiplication, right? Then what do I mean by this is, if you are taking row by column multiplication, then here if you are taking the element 1 1, it means that you take the first row from delta 1 and first column from delta 2 and you multiply them. And if you are looking for the element 1 2, it means that you take first row from delta 1 and second column from delta 2. 1 3 means first row from delta 1 and third column from delta 2, and you multiply the corresponding elements and you write them there. In case if you are talking about row by row multiplication, in order to get the product, it means that if you want the 1 1 element of delta 3, then take the first row of delta 1 and first row of delta 2, because it is row by row, first row and first row, right? And you get this element. And in order to get this element, take the first row of delta 1 and the second row of delta 2 and you get this. Similarly, if you are talking about column by row multiplication, it means that if you want 1 1 element here, take the first column of delta 1 and then first row of delta 2 and you multiply them. Likewise you can do this, okay? So here I have taken row by column multiplication. In this case, whatever order you take, either row by row or row by column, the result is going to be same because they are symmetric matrices. Now when I am talking about row by column, see, first row is multiplied with first column in order to get this element. Check that corresponding elements are multiplied, ax, by, cz, right? And then in order to get this element, which is 1 2, first row and the second column, so first row is multiplied with the second column. So it is normal matrix multiplication, if you remember. It is just the way how we multiply the matrices. So check this, ay, bz, cx, ay, bz, cx, and this one is 1 3, which means first row and third column, which is az, bx, cy, az, bx, cy. Got it? So now if we observe it, once we have multiplied them, you can replace each of these terms, each of these elements with u, v and w. You can check each of one. So I have replaced each one with u, v and w. How? Because it is already given that u is this, v is this and w is this. And after replacing this, already we have solved this determinant of this. Anyway, I am solving it again here. So I am expanding this across first column. Okay, if I expand it across first column, what I am going to get is u into this one and then minus w into this one, right? So likewise you can get this. So once you expand it, this is the final answer. The final answer is u cube plus v cube plus w cube minus 3uvw. So we have expressed the determinant in a way that it is asked. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.